Welcome to the NX CAM session. In this session, we can see contour area operation. The name itself indicates contour. It is meant for dome shape or a flat surface for machining. Now, in this example, we have taken a cavity of drone. First, we need to set MCS. Right now, it is MCS is downwards. I would like to machine this yellowish region. I need to change MCS. To change MCS, click on MCS, right click on MCS, go for edit or double click, both are same. You can see here there are methods to rotate. Here you can use this or this one, it is up to you. I want to rotate through y-axis, so click on this and selection filter, select the y-axis and mention the angle. Now I would like to rotate it 180 degree, so I have rotated. After this I need to select this workpiece. For a finishing operation, blank is not required. You can select only part geometry, and when I select this part geometry, whenever I do select like this also, it is not selecting. Why? Because in selection filter it has by default it came as solid body. Here you need to change it to sheet body or face if you want to consider the patches which you did by using n-sided surface or patch surface or any other method. So once you select the workpiece, then go for creating operation. Create operation, select a contour area. This is recommended for finishing operation. Here we need to select create a cutter. These are the tool types which are supported for this operation. For this shape, ball mill is the best cutter for this. Select ball mill with the diameter 10. I am mentioning diameter 10 mm. Length, if you want to reduce, I can reduce it to 50. Loop length, if it is 30, you can give it. And tool number, whatever you give your tool number, that will be there. And adjust register is nothing but your H value. Here also I will give same. For this example, I will take holder from library, milling and drilling category, select OK, and select any. You can see here the preview of the cutter. Hit OK. After that, you want to machine steep region. Steep region nothing but this inclined or vertical wall. Non-steep region means this flat portion or dome shape which you are interested. And from here we need to select which method we are going to select. If you take both steep and non-steep, then you have to decide whether you want to cut first steep region, then non-steep region. Then you need to mention here order region as steep first. Then what it will do, it will first machine this vertical or inclined walls, then it will go for the non-steep region. Right now I am interested only in machining non-steep region. Steep region I will machine with the help of Z level or other operation. I am focused on non-steep, so I will take non-steep only here. Then that option of first steep, first non-steep, that option will disappear automatically. Then if you want to overlap the region, if you have selected, then you need to give a distance how much you want to overlap, so that two different regions if you have selected, then if you take overlap, then there will not be any mismatch in the surface. If you want to avoid a mismatch in two different surfaces which you are machining, that time you have to give overlap region. Here I am selecting entire region, so I am keeping none. Steep angle I kept 60 degree. It means whichever surface which is 60 degree with the horizontal, then it will machine. You can increase or decrease the value depending on your interest. In non-steep cut pattern, there are multiple options which are available. If you are machining egg shape or dome shape, then you go for spiral. In another words, if you are making any electrode, that time you go for spiral, where it will have one entry, one exit in spiral. Non-cutting moves will be lesser for those kind of shape. Depending on the shape, you need to select cut pattern. For this example, follow periphery is suitable. Suppose if your surface is flat, then you go for zigzag. If you want only one pass, then you keep profile. It depends on you. Now I will take follow periphery. Right now I am using cavity, so I will keep pattern direction as inward. If it is core, then I will keep outward. What does it mean, this inward? Means first the cutting will start from outside, then gradually it will come towards the center. So it cut direction we call it as inward. If you keep outward, then what happens? Initially it will start from the center, then it will go towards the boundary. Depending on the shape, you need to decide. For this particular example, inward is the best option. If it is a core, then I would have taken outward. As this is cavity, I kept inward. Cut direction, whether you want a clean cut or conventional cut, you need to devise. It is nothing but, clean cut is nothing but your workpiece direction and chip direction is in opposite direction. Conventional cut means both are in same direction. It is nothing but the concept of up milling and down milling. One pass, if it gets completed, then how much we want to shift, that is nothing but step over. Here you can give scallop, tool fare percentage, multiple or constant value. If you know exact proper value of constant, then give it. Many people will try to use scallop depending on your mode and also interest. Here I will give scallop and I will mention 0.03. If you want to clean up step over, then you need to turn on this. If you want to do smoothing, don't want to see any jerk movements, then you can keep path smoothing. It depends on all your need. After that, go to the geometry where you want to machine. That region you have to select in specify cut area, or you can specify trim boundary. It is up to you. Whichever you want to do, feel easy, you have to select that. For this example, I am taking specify cut area. Select and go for selecting the surfaces. If I keep single face, then every single face I need to select. Tangent faces I will take and I will select this face, which are all tangent, that has selected, and also I will select this patch. You can see that preview. Even though I have selected steep area, it will avoid that steep area. Why? Because in main we kept non-steep only. Mention stock if you want to keep, like 0.1 stock you want to give, then later you want to finish, then give part stock here. Everywhere it will maintain the same stock. If any time if you had used check or clamping, that time your clamping size is smaller, and if you want to increase that size from here, you need to specify, so that your for example, if someone has clamped at a corner and the manual error, if he shifts 1 mm 2 mm here and there, then there might be chances of cutting that 1 mm in the fixture or holder which is used to clamp. So if you want to keep safer side, that time you can give check stock, so that if it cutter will not cut that region. If you want to do local machining, then you can take trim boundary. Tool axis I kept Z axis, and feed and speed I will specify according to my need. In one more session we can see this what exactly this set machine data means, how to set data of this particular cutter, and whenever you click this, whatever feed and speed with the cutter, that has to update. Within a click you can update the feed and speed. That we will see in some other session. In strategy you can have this extended edges. If you want to have last pass at your edges, if some material is leaving behind, then you need to give extended edges. Otherwise, if sometime if edge is also there, if you want to go up to the outside, then you have to keep roll tool over edges. If you want to extend at convex surfaces, here you need to turn on. And best part, you need whenever you face any chatter mark, that time you have to reduce feed at complex, or whenever there is a cutter direction change, you need to reduce feed. That can be done with the help of feed adjustment on all arc. You need to turn on for all the arcs, and here you need to mention compensation factor. What does it mean? For example, if I specify 0.5 and 1. So this means whenever there is a sudden change in the direction or arc radius is smaller, then it will try to take feed of 50%. 0.5 factor means 50%. If arc ends, then linear starts. So during linear it has to take feed of 100%. Or if arc is smooth or the radius is bigger, that time it will depend on the radius of curvature or complexity of that arc, and it will decide the factor. Sometime it may be 0.5, sometime it may be 0.7, sometime it may be 0.9, depending on the shape of the arc. So this you need to keep in mind to avoid chatter mark in the corner. And also, if you want to slow down the corners before entering into the corner region, if you want to slow down, or whatever the factor which is having that you want to acquire, that you can give by using this slow down distance. Here you can specify in terms of percentage. If you use previous tool diameter also you can specify, means from there the feed will be lesser whenever it is entering into the arc region. These are the important factors you need to keep in mind. Whenever you want to turn on the smoothing, turn on, so that non-cutting moves will be lesser. And here it depends on this value. Whenever there is a two consecutive actions or tool path you are taking, that time if the distance is 100%, then it will make a smooth pass. If it is more than that, then it will lift and go to the other region. This factor will help you to decide. In avoidance, from where it has to come, start point, from where it has to start, this you have to mention. Home point usually we specify in host processor. Automatically home point it will take it and it will do. While doing retract and engage, if you want to do smoothing, you have to specify. It all depends. If you turn on, you can see that, but many people are not interested in this. Tolerance and other thing you need to specify here. It is taking 30 micron. What does it mean, tolerance? Whenever there is a straight line, it will be divided in points. Those points are nothing but with the 0.03 it is taking. If you find that arc movement is not smooth, if you want to make smooth, then you have to change this tolerance or reduce the tolerances. You can see in this image what I would like to tell you. If I am making an arc, if I give 1 mm, in tolerance, then it will create points on the arc with a 1 mm. Then you can see arc you will not get, you will get like a, if it's a hexagon, heptagon, or like that sharp edges will come. So if you want to have that arc accurate and with smooth radius, then you have to reduce tolerance. Here I will prefer for finishing, go for finish. Here you can see tolerance automatically change it to 10 micron. If your expectations are high, then you reduce this value. Some people will ask me the question like, sir, whenever I do the shape of arc or something, that time I am not getting exact shape because of the tolerance. Keep in a mind. Collision, whether whenever it is having a collision, it will skip if you turn on this option on. It means whatever the toolpath is getting created, that will be in safer region. In another words, whatever it is machining, it is safe. It will not generate the toolpath where it is getting collided by with the help of this option. Generate the operation. Can you see how it is generated? Verify. Reply only I will show you. Why? Because I have not selected any raw material. I can increase this animation speed. Like this, you have to use area milling operation. Thank you.